Okay, ID. This is for define the problem for project 2.2.8, design and integrated assembly. So we made these carabiner pins, and your thought process is you're going to be creating a accessory for this, and it's very open-ended about what you could actually create. And you're going to notice that my videos are very vague, and they're not going to really tell you specifically what to make. That's because it's your job to try to figure out what kind of accessory you want to create. I'm just going through and I'm just telling you what I'm going to be grading you guys over because you're going to be the one that's responsible for creating this stuff. So for the first section that I'm going to be grading you on is define the problem. And there's a whole lot of different things that you can do for defining the problem. As with all design aspects, the first step is to clearly define the problem and determine the relevant criteria and constraints. So here's a couple of things that we can do. Okay, we have done a visual, a functional, and a structural analysis of the product that you reverse engineered. So we did that for a different object. So what you might want to do is, well, no, I have to take that back. Yeah, we did do a visual, functional, and structural. So you can go back and you can review the analysis of these individual parts. The next thing that you would want to do is you would want to define the client, the target consumer, and the designer. Hopefully, the designer is you. But the target consumer is going to really depend on what you make. Record this information inside your design brief. So there's going to be a design brief. There's a link that you can click on to get the design brief. If you are not a part of my class and you're virtual for some other class for Intro to Engineering, you can just go to the Project Lead the Way website, and they do have a design brief link as well that you can get to. All right, so it says also write a concise problem statement. For a reverse engineering project, the problem statement should include a clear definition of the problem or the opportunity. So consider the following as you formulate your problem statement. From the customer's perspective, what are the needs and expectations of a customer using this product? In other words, what do the customers need that they don't know that they need? So you're trying to make an accessory. So you want them to, whenever they see that, to be like, oh my gosh, I want that. Which you've probably had happen to you several different times in your life too. You've seen something that was an accessory to a phone or an accessory to, I mean, just anything, and you're like, wow, that makes things so much better. That's really what you're looking for. You're trying to find some kind of need that needs to be filled for this accessory. From the engineer's perspective, why is the issue you identified a problem from an engineering perspective? So, is there a problem that needs to be solved? You know, does this already exist? If it does already exist, why are you making it again? Because there's no point. So make sure that you're actually like solving a problem for the pin. Okay, and then the reflection, will you solve the problem that you identified during reverse engineering, or will you exploit an opportunity to develop a useful or desirable product for the target consumer? It kind of depends on what you're going to be doing. You could try to optimize the pin, and that would kind of be like a reverse engineering type way to go about this, or you could try to fill some kind of need. It's, you know, that's going to be up to you guys. It kind of depends on what you want to do. Next thing is write a design statement. Think about how you hope to discover or what you want to show to meet the needs of the customer. This design statement is going to be different from what we've done before because since you have the free reign to be able to make whatever you want to do, everybody's design statement is going to be a little bit different because it all depends on what you're trying to do. So I look forward to seeing these design statements. They shouldn't be copies of each other because everybody's going to be making something different. Also, consider the overall functionality of the system, such as input and output relationships. Write measurable criteria and constraints that will support the functional requirements. So if you're adding an accessory, you need to have some kind of constraints to that accessory as well. So you need to think about, you know, how big do I need to make this, and that can be a measurable criteria. You can also measure how functional it is by testing it afterwards. So come up with an idea. If you're trying to make something better, try to come up with how do you know that you actually made it better? How can you measure it? Can you just like time somebody doing it? Can you see whether or not it fits within a certain volume or area or something like that? There's got to be some kind of measurable criteria in order for your design to be putting constraints. Okay, if you start with everything, then you have nothing. And what I mean by that is you can't just say like I'm going to design something and be like I have all the options in the world because if you start with all the options, you're not going to choose. You're not going to basically you have to force yourself in and adding these constraints actually makes your life easier, I promise. Okay, so this is in general what I need for it to find the problem. There's a lot of information there, and there's a lot of different things that I'm going to need for it as well too. So if you just turn in a one-sentence design statement, you're not going to get graded very well. So please make sure that you give me as much evidence as you can that shows me that you are doing the engineering process properly and defining the problem needs proper time to be worked on. And that's really all I need to say about this one. So I hope you guys have a great day, and I'll talk to you later.